Good morning, guys. So today we're going to talk about the mean absolute deviation. And I don't want you to freak out about that name. It sounds kind of scary, but it's really actually very simple to do. It's basic math, all right? So, mean absolute deviation is the average distance between each data point and the average of the set. So that sounds kind of weird to read. The average distance between each data point and the average of the set. So all that means is you take the average of everything and you want to know how far off the average is each individual data point. And once you find how far each one is, then you average those numbers. So it's really not hard. You can see across the top where it says average, subtract, average. That's all we're doing today, okay? And so let's look at our steps. It says the first thing you're going to do is find the mean of your data set, okay? We know mean is the same thing as average. So whichever word you're more comfortable with. If you're more comfortable with mean, great. If you're more comfortable with average, that's fine too. If you like mean better, it's mean, subtract, mean. Okay? Now, the second one is the difference. That's the subtract part. You're actually going to take the average of all the numbers in the data set, and you're going to subtract that average from every single number in the set. And then, for the very last set, you're going to average the absolute value of those answers. And here's where it's important. That absolute value is super important. Even though it looks like it threw up a ink blob right here, but that absolute value is important. But let's talk about what absolute value is. Absolute value is how far something is. The distance from zero, okay? So let's think about a number line, okay? We just finished with scientific notation. Now, in scientific notation, that exponent showed us that how many hops we went, right? So how many times we moved the decimal. Well, the negative told me the direction, but in the end, I needed to know that specifically how many hops. Well, it's the same thing here. Absolute value doesn't care if you're going to the left on the number line or the right on the number line. It wants to know how many hops it took you to get there. For example, with our distances, sometimes direction is important and sometimes it's not, okay? So let's think. If I'm giving directions and I'm going to say you're going to go 5 miles down the road. Well, 5 miles is a long way to go the wrong direction. So if I get a stop sign and I turn to the left and go 5 miles and then they come back and say, oh, no. You're supposed to go right at the stop sign. Well, then I'm 10 miles from where I need to be, okay? So that in that situation, the distance is important. Now, if I say, oh, I got up this morning and I jogged a mile, does it really matter what direction I went in? No. If I went down to the track at the middle school and I ran a mile, well, I just went in a circle 4 times, okay? In that case, the direction's not important. So with absolute value, we're not worried about the direction. We don't care if you went forwards around the circle or backwards around the circle when you ran this morning. We just wanted to know how far overall you drove. Sometimes those directions are important, like when you're driving. But other times, we just want to know the overall distance. And so today, we're going to worry with the absolute value and not necessarily negatives or positives. Let's look at a couple examples and see what I mean. Because right now, this probably sounds pretty overwhelming. But again, I promise, it's super, super basic. Okay, so for example number 1. And notice this only has the actual table, but if you're following along in your notes, it says the boys basketball team recorded their scores from 10 games this season. The scores are shown in the table below. Find the mean absolute deviation of the set of data. Now, I didn't have enough room to have all of those words and be able to write this for you, so mine just has the table, but just follow along in your notes, okay? Now, I'm going to set up my table. And I'm just going to do basic. And remember, the first thing I need to do with this is I need to find my mean. So I'm going to fill in my data. My first number is 41, 30. Ooh, 37, 50, 38, 46, 54, 42, 56, 49, and 47. Now, I always count these to make sure I have the right number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 matches the table. I'm good to go. Now, so to find the mean, I have to add up all the numbers and divide by how many there are. So I need to add up all of these. And if I add up all of these, I'm going to get 460. Now, I have 460, but what do I have to do? I have to divide by how many there are. So I'm going to have to say 460 divided by 10, because there's 10 of them. Now, 460 divided by 10 we know is 46. All right? So, now that I have my mean for the data, I'm actually going to go in and I am going to subtract. So remember I said that mean absolute deviation is just average, subtract, average. So I've averaged the first set of numbers. Now I'm going to go in and I'm actually going to subtract the average from each individual set. So I'm going to have to do 41 minus 46. 37 minus 46, 50 minus 46, 38. Okay, you can see the pattern. I'm just going to go in and subtract 46 from each individual one. And I like to go through and write it first and then worry about doing the math. If you want to do it as you go, that's fine too. All right? So, 41 minus 46 is negative 5. 37 minus 6 is negative 9. 50 minus 46 is just 4. 38 minus 6 is negative 8. 46 minus 46 is 0. 54 minus 46 is 8. 42 minus 46 is negative 4. 56 minus 46 is 10. 49 minus 46 is 3. And 47 minus 46 is just 1. Now, remember, this mean absolute deviation, this A goes in this middle column. So I'm worried about the absolute value. So I'm going to go through and I'm going to circle all the negatives I got. I had a negative 5, a negative 9, a negative 8, and a negative 4. Now, when I want to know the absolute value, I'm not worried about the distance. I don't care if it was 5 hops to the left or 5 hops to the right. I just need to know that it's that basic 5. So I'm actually going to go through and I'm going to make these positives. So I'm only wanting to work with positive numbers for this particular one. All right. So now I'm going to bring that into my deviation column because I need to know how far each number deviates off the average. So I'm going to bring over my 5, 9, 4, 8, 0, 8, 4, 10, 3, and 1. And I'm going to count those one more time to make sure I have all my numbers. 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay. So now, remember I said mean absolute deviation is average, subtract, average. So we have actually went in and we found the mean. We have subtracted each one, and now we have to find the mean or the average of this last one. So I'm going to add all these up, and I got 52. Okay, and I have to take that 52 and I'm going to divide it by how many numbers there are, and there's still 10 numbers. So that means my mean absolute deviation is going to be 5.2. Okay, so again, all we're doing is we're finding the average of every single number in the table, and we subtract every single one of those numbers by your average, and then you have to tell me how far it deviates off of each one, and then you're going to find the average of that deviation. Okay, so again, we averaged then we subtracted the average, and then we averaged the absolute value of the answers. Okay? So let's try a couple more. Again, if you're following along in the notes, example 2 says the number of runs allowed by a pitcher on the baseball team was recorded for his last 9 starts in a game. The results are shown in the table below. Find the mean absolute deviation of the data. Okay, so pitcher's throwing a game. These are the number of runs he allowed for the start of each game. All right, so we are going to find the mean absolute deviation. The first thing I need to do is I need to set up my table, and I'm going to find the average of each piece of data. So mean absolute deviation, first one is mean. So I'm going to fill in these numbers. So 0, 8, 6, 4, 5, 5, 2, 6, 0. Now, and I always have kids ask me, do I have to write the zeros? Or the zeros important? And the answer is yes, because when we get to the subtraction part, you're actually going to have to subtract from that 0. And so make sure you're actually writing in those zeros, okay? So to find the mean, we know we add all these up. And when you add them all up, you get 36. And I have to divide by how many numbers there are. And there were 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know 36 divided by 9 is just 4. All right. So remember, average, subtract, average. So we found the average of the first one. And now we're going to go through and we are going to subtract each individual number. All right. So 0 minus 4. And I'm actually just going to go write minus 4 on each one before I start worrying with the math. So it's all ready to go for me. Again, if you want to do it as you go, that's fine. It just helps me to, once I start getting in the subtract frame of mind, that I just keep going, all right? So 0 minus 4 is negative 4. 8 minus 4 is 4. 6 minus 4 is 2. 4 minus 4 is 0. 5 minus 4 is 1. 5 minus 4 is 1. 2 minus 4 is negative 2. Oops, I didn't write that. There we go. And 6 minus 4 is 2. And 0 minus 4 is negative 4. Now, remember, in this column, this is the absolute column. So, we found the mean. Now we're in the absolute column. That absolute column means absolute value. So, I'm going to go through, and I'm going to circle my negatives. I have a negative 4, a negative 2, and another negative 4. And I only want the number of hops, okay? So I'm worried about how far it is off the average. So it is 4 points off, or 4 runs off the average. And so I'm actually going to make all of those positives before I go over into my deviation column. All right, so my last column is my deviation column. And so I want to know how far it deviated off the average. So this one deviated 4, 4, 2, 0, 1, 1, 2, 2, and 4. Okay? And remember, it's average, subtract, average. So I've found the average, I've subtracted each one, now I have to find my final average. Okay? And so when I add all these up, I got 20. And remember, we have to actually divide by how many numbers there are, and there are 9. And 20 divided by 9 is just 2.2, and that 2 is actually repeating. So my mean absolute deviation for this problem is 2.2, okay, or 2.2 repeating. All right, let's do one more example. Example 3 states, the table below shows the high temperature in the Bay Area for 1 week during the month of March. Find the mean absolute deviation for this set of data. All right, so again, we're going to set up our table. And the first column is our mean column. And so let's go through and let's fill in our data points. So my first number is 60, 64, 62, 68, 70, 72, and 66. Now I'm going to add all of those up because it is mean absolute deviation, so I have to find that mean for the first time. And when I add these up, I get 462. And I have to divide that number by how many there are. So if I count this, there are 7. 462 divided by 7, just typed it in my calculator, and I got 66. Okay, so what I have to do now for my absolute column is I'm going to subtract each one of those numbers by the mean of the data set, which was 66. So I'm going to subtract 66 from each individual number. Remember, I like to go in and write all of this first, but you can answer it as you go. So 60 minus 66 is negative 6. 64 minus 66 is negative 2. 62 minus 66 is negative 4. 68 minus 66 is 2. 70 minus 66 is 4. 72 minus 66 is 6. And 66 minus 6 is just 0. Alright. Now, again, this is the absolute column. So, I'm going to go through and I'm going to circle all my negatives. And it's just these first 3 right here. But I want to know how far I'm off the average. Okay, I don't care in which direction. I just want to know how far off the average. So, for this, I'm going to take the absolute value and just make those positives. Alright, and my last column is the deviation column. I want to know how far, or the average deviation, okay? So, I'm going to bring those numbers over here. So, I had 6, 2, 4, 2, 4, 6, and 0. And I'm going to add them all up. I got 24. And I have to divide that by how many numbers there were in the data set. And there were 7. And I got 3.42 ... Okay. And I just want to keep it to the tens place, so I'm going to go behind it. 5 or more, raise the score. 4 or less, let it rest. So that's going to stay as 3.4. And so that is going to be my mean absolute deviation. Alright, guys. So, again, mean absolute deviation, when you see that word, or even when you're explaining that word, it sounds really scary. So if you go home and you tell your parents, hey, I learned about mean absolute deviation, it sounds super complicated and they're going to be super impressed. But really, all we're doing is we are averaging, then subtracting, and averaging those absolute value of the answers, okay? So, the most important part that you cannot forget is the absolute deviation, or the absolute value. If you mess that up, you're going to get the whole thing wrong, okay? So the biggest thing I can say is remember that absolute value and check your math with the calculator. If you are not 100% sure, there is no shame in your game to use the calculator, okay, guys? Because I would rather you use your calculator and get them 100% right than try and go through without it and you accidentally mess up one little thing. Alright, so if you have any questions, just email me and let me know. But otherwise, have a great day, and I will see y'all later.